We are live. Hello, good afternoon, everyone.
Oh, they can hear us.
Thanks for hanging out here, day 4, lunch hour, and day 5 and 6 if you are a partner and you are here on Saturday and Sunday. So we appreciate you joining the session. This is a networking best practices for virtual SAN session. My name is Bhumik Patel. I'm a partner architect at VMware. And we have John Kennedy, a UCS TME, with me on the stage. Thanks for your time, John, here. So, standard disclaimer, let's look at the agenda today, right? So we'll basically look at the vSAN networking requirements. We'll go through how multicasting works, since it's a critical component of vSAN. We'll look at some of the best practices from a end-to-end vSAN networking perspective. We'll look at some configuration examples on the switch and router side, and then we'll give you some troubleshooting tips, and then take Q&A at the end, okay? So, I mean, a lot of new stuff around vSAN 6.1 announced this week. A lot of excitement overall on vSAN since we've launched, right? 2,000 plus customers, a lot of cool stuff, all flash storage, SPBM, we can do software-defined storaging. So, you know, overall, we are seeing great momentum. The question you would ask is, and I'm going to ask that to John, is why are we having a session on networking for vSAN, right? John, what are your thoughts? You want to share any?
Hi, my name's John Kennedy. I'm a UCS TME at Cisco. And as a UCS TME, I see things from the perspective of a VMware admin. Now, when I look at virtual SAN, I see that virtual SAN relies heavily on networking. And to complicate things, virtual SAN relies on multicast networking, which is exceptionally daunting. Even network admins don't like it. Now combine that with the fact that you as a virtualization admin may or may not have control of the switches that are part of your vSAN backbone. When you put all three of those together, you can find yourself responsible for a virtual SAN, but not able to control the backbone that makes it all work. Notice the paddle. Notice the canoe, notice you. That's why we wrote this presentation, to help you and give you some tips and tricks to make sure that if you do not have control of the network, that the networking guys understand what you need, and you can help troubleshoot the problem. And if you do have control of the network, that you have the tools you need to actually control the network. Because many of us are not necessarily network admins. And I'd like to take a quick poll. How many people are network admins? How many people really understand multicast? Yeah, the number's less, I can tell. Yeah. And most people are not network admins in here. You're mostly all vSphere administrators from what I can tell, or just, you know, shy. So we're targeting the presentation correctly.
Thanks, John. So, for the networking guys, if you are not familiar with vSAN, right, just a quick snapshot of what vSAN is. Obviously built into kernel, ESX kernel, and 3 nodes minimum, although we did announce 2-node robo this week with a third witness node that is an embedded VM that can run in your data center, right? So 3 nodes standard minimum, all the way up to 64 nodes. All nodes contribute storage, right? So we were just having this conversation just now is nothing stopping you from having compute nodes and storage nodes, but we don't recommend them to be like an unbalanced config, what we call them, right? So all nodes must contribute storage, and then this is obviously both hybrid and all-flash configuration that we support, right? So locally attached disks and high-density disks. All right, so let's look at the communications and the roles in a vSAN cluster before we look at the networking best practices and requirements, right? So at a high level, there are 3 types of roles within a vSAN cluster, right? It could be a master, backup node, or an agents, right? So, and this is internal to vSAN, right? As an admin, we don't have, this is not an explicit control over selection of masters and these different roles. This is done during the cluster discovery mode. Right, so from a master perspective, all nodes contribute to an election, and then we have a master node that is responsible for making sure all the nodes in vSAN are actively participating in the cluster, and it does that via the CMMDS service, the Cluster Monitoring Membership Directory Services, which will take care of all the, this is what we use to do health checks between the nodes, right? So all the metadata information that the master needs from the nodes is done via the CMMDS service. And then what the master does, one of the things the master would do is take this and give it to the backup node and then the agent node as well, right? From a backup perspective, it's there. In case the master fails, it needs to take over and become a master. So it has all the contents, all the metadata and the object information to make that process a relatively seamless process, right? So if your master goes down, it doesn't need to go somewhere, look for data. It already has this information. So let's look at the communications, right? So there are 3 different types of communications that are of interest here, right? So first is a communication between all nodes. And this is done through multicasting. This is, again, one of the things the master does is does the ping every 1 second, right? It's going to do a heartbeat every second to make sure all nodes participate in the cluster. This is done via multicasting. And then all the nodes, right, if a node A needs any metadata information from another node, it will do this through multicasting as well, right? So between the nodes as well, there is a multicast communication going on, right? So, and the reason for this is vSAN is object-based storage, right? So a VM will have multiple objects as its components. So you could have a compute node, and then the object might be on a different node. So when a read comes in, it will talk over the network, right, to get the object information. So that's the metadata communication, right? The second one is between the master and the between the roles, right? Between the master, backup, and the agent. And this is relatively light because this is only the updates that the master needs to send. So this is still multicasting, but this is relatively light compared to the first one, right? And then the third one is the normal disk I/O traffic, right? So this is the read writes, this is the object information. But it still goes through the network, as I mentioned, right? It's a distributed object-based storage. So if a read comes in, if you need an object info from a different node, that information is going to come over the network. But this is unicast, okay? So these are the 3 types of communications that you would see in a vSAN cluster. So now look at the networking requirements, right? So 1 gig versus 10 gig. For hybrid vSAN, 1 gig is supported. Obviously, we recommend 10 gig. But for all flash, 10 gig is a requirement, right? We don't support 1 gig for all flash vSAN. From a VMNIC perspective, vSAN needs obviously a dedicated VM kernel on the host, right? So that's a requirement, and it's supported with standard switch and distributed switch, right? So those are the 2 switches that we support. We recommend using distributed switch because you can leverage the operational benefits. But one of the reasons is also obviously, you can do the NIOC share configurations, and we'll talk about those later. But with vSAN, you have the VDS distributed switch license available as part of it, right? So normally you need Enterprise Plus, but with vSAN, you already have a distributed switch license. All right, so we talked about multicasting. We looked at the communications that use multicasting, the metadata information. So why do we use multicasting, right? So think about it, right? So all the nodes are talking metadata between each other, and if we would do unicast, then this would be a lot of duplicates, right? So not only that would cause CPU overhead on the host, but also network overhead within the cluster network, right? So this is why we use multicasting within the nodes for the metadata communications, right? So that's a requirement, and we'll talk about how multicasting works. John's going to explain us how it works on different networking topologies, and then we'll look at some of the things you need to consider when things don't seem that they're working fine. All right, and the last one is not as much as a requirement, but generally speaking on vSAN, all your vSphere networking best practices still apply. So you still want to continue to apply your platform level best practices. So for isolation, you want to do separate VLANs for vSAN traffic and your other traffic sources. And then you want to use network I/O control for a QoS mechanism, right? So those are the recommendations on the QoS side or on the traffic isolation side, right? Use VLANs, do NIOC. One thing we do not recommend is you don't need things like priority flow control for vSAN. And the reason being is priority flow control is a mechanism on layer 2, right? It works at layer 2 versus when you put multicasting on top of it, which is more like a bursty traffic, it doesn't go well, right? So again, nothing stops you from configuring those things, but in our testing, we've seen that there's not much benefit you get from configuring priority flow controls on a NIC level. Instead, you wanna do network I/O control and configure shares for your QoS. All right, so from a ports perspective, from a requirements, these are the firewall ports you need. The first one being a vSAN vendor provider, right? So just like VASA provider for external storage, vSAN has its own vendor provider, and that's the TCP 8080 port. So this needs to be open between the ESX host and the vCenter, right? The next one is CMMDS, the service I mentioned. So this is a highly available and efficient network service, right? So this is what the RDT protocol, which is a proprietary implementation within vSAN, uses, right? So RDT is over TCP. It uses CMMDS to do this metadata updates. So these are the two, UDP 1230. 12345, 23451, and RDT, TCP 2233 are the ports you need for those. One thing to keep in mind here is in case you are, we announced stretch clusters here this week. We'll talk about vSAN over layer 3. In case you are doing multi-site vSAN, these ports need to be open between sites, right? Because this is using node-to-node, this is node-to-node communication. So you need to open these ports between sites, right? So if you're doing any design where you have fault domains across sites or stretch cluster, that's something to keep in mind. And then the vSAN Observer is a monitoring tool. So if you're using that, that's the port it works on.
Somebody actually chose port 12345.
Yes. The question is, did someone actually consciously choose port 12345? I'm sure they did. I don't know. I wasn't there, but I mean, I would imagine. It was a conscious choice, yeah. And as was 23451 if you get the algorithm he's trying to do there.
So let's talk about how multicasting works, and then I'll pass that.
You know what? Before we do that, just one thing I wanted to point out, and you said this, and I want to reinforce it because I think it's going to be important for your troubleshooting efforts. Right there. Those port numbers are necessary. Now, you normally won't have to configure a firewall to open these normally because you're talking between ESX and vCenter and ESX and ESX, and there's typically not a firewall in the way. And the firewalls that exist on the vCenter and the ESX, that's all taken care of for you. vCenter will take care of that. But it's good to know those port numbers just in case, and you will see why later, but keep 12345 and the other one, 23451, in mind. That's okay, I got the thing. Okay, I got that. I'll just do this. Just keep those in mind. So multicasting. Here is an amateur's concept of multicasting. If you're like me, your understanding of networking as a server admin, as I was before I came to Cisco. I was at VMware for a long time, and then I came to Cisco about 5 years ago. And your understanding of networking consists of subnet mask and gateway. You know what an IP address is. You can typically mask it. I mean, you typically know how to get to the gateway and what goes through the gateway and what doesn't. And that's usually a server admin's level of understanding of networking, or at least it was of mine. In 5 years at Cisco, I can say I've picked up a little networking. It's like moving to Italy. You learn Italian eventually. So what is multicasting? It's a lot like broadcasting, only broadcasting is to everybody. And it's designed to go on one address, and then every NIC in the world is designed to read that address. And it's for everybody. It pelts everyone. And sometimes you need that. Can someone who's not a network admin tell me why you would need in what case would you need broadcasting? ARP resolution, thank you. Anytime you want to know a MAC address, right? You don't know the MAC address of who you want to talk to, you have the IP address, you have to ARP it, and then that gives you the MAC address. So that's broadcasting, and that has to happen sometimes, but we love to avoid it because that's a ton of network traffic. The idea behind multicasting is to put up a set of casting but it only goes to the people who want it, and it only goes to the NICs that want it. It's only for, you would call it subscribers. Now, individual hosts, or you can think of them as individual NICs, will register for multicast information or data, casts, multicasts, by indicating the address of the multicast they want to listen to. And those addresses are within a reserved route, a reserved section. Now, I know, network guys, please don't beat me up. I realize it says Class D on there, and nobody says Class D anymore. But that's kind of what it is. It's that range of addresses that the first bits start with 1110. Those are multicast addresses, and just about every switch, just about every NIC is designed to see those differently. It's designed to see those in a way that they understand how multicast is, and they can let it through or they can just drop it. And that address is how the switch identifies a multicast packet or a multicast group. A group will be an address, a particular address. When the switch sees that packet, it will send that packet with that address to all the ports that have registered to be part of that multicast group. Okay. Normal operation. And we'll talk about the differences in a second. Snooping. Now, originally, multicast were just, the switch didn't really, it understood what multicast was, but originally, it sent multicast to everybody. Just all the switch, all the ports. It's just the easiest way to deal with it. And many switches will continue to do that, unless you turn on this thing called multicast snooping. Multicast snooping actually listens to which NICs want the multicast packets. And when it does that, it's going to create a little database that says, okay, here's the ports that have those NICs that are interested in this multicast group. It's going to keep a database. Switches originally didn't do that. That was reserved for routers. Routers were the only ones that did that, and they wound up flooding a whole switch and a whole L2. Because all that multicast traffic was just too much. And so now the switch remembers those ports. Now, what can happen with IGMP snooping? And if you look really hard at this slide, you'll eventually go blind. I apologize for this slide. It should be 2 slides. It should be more clear. I'll work on that. What I'm trying to get across is, simply put, the switches, in many cases, do not register their uplinks as multicast targets. That is, they hear that a multicast address is available. They do not send it out their uplinks. They interpret these as a downstream thing in many cases. In this case, I've got a peer link between these 2 switches. That implies something like a VPC or switch stacking or something like that. They've actually, in some cases, had to add to the VPC code a multicast router type function just to get these packets across from one to the other. And typically, if you have some of these newer switches, that just setting up the VPC will be enough. It'll take care of it, so that your multicast will get from place to place. Now here, I have a multicast. It's a registration coming off of this B side, but this is the B server, but it's going up on the A fabric. So registration is going up to the A fabric. The A fabric then remembers, oh yeah, that port wants multicast packets on this particular address. Now, what happens when this server sends the multicast, because this is a send and receive situation, vSAN is sending as well as receiving, and it sends the multicast, but it sends it to the B switch. Because it's an LACP, it can only go to one side or the other at a time. Otherwise, you have a loop. So when it goes to the B side, this server never sees it, because this switch does not consider the uplinks to be a place to send multicast information. This was the problem I had on the Cisco. Anybody here use Cisco UCS? Holy, whoa, I wish I'd taken a picture of that. Thank you. I'm gratified to hear that. It means that everybody who uses Cisco UCS also fails to get so drunk at the party that they can't make it the next day. That's gratifying to know. Thank you. This is the problem I had with Cisco UCS because they have no peer links, and even if they did, the peer links that you get from connecting it to an upstream switch, they wouldn't send the packets out there. So they would never register those things. So what I had to do to get around that was use a thing called a Querier. This is a weird system. I got to tell you right now, IGMP Querier is a weird system. So we invent snooping so that we know which ports want the packets. But the switches eventually may forget, or they may be on uplinks. The packets may come on uplinks that the switches don't understand. So turning on the IGMP Querier actually makes the switch ask the ports what multicast groups they want to be in. It's a way of saying, what multicast groups are you interested in? And then the servers respond. And when you do that, the database in this previous switch will update and let the packets go through the uplinks. It will say, okay, I can now register the uplink, and I know the uplink wants this information, and it will do it. This is what happened to me with UCS, and it could be what happens to you with your systems. Upshot is, it acts like an M router, and I'm not going to go over all of that, but upshot is, turn on the dang Querier. Just do it. Just do it. Don't ask why. Just do it. Question in the back. I'm sorry, I too much rock and roll as a kid.
Use the mic, please.
That's amazing. The mic is not helping. Is the mic on? Okay.
Where do you enable that?
Oh, where do you enable that?
UCS
Well,
side or
so where do you enable that? On your switch. It's going to be different for every switch manufacturer. Let me start there. On UCS, we have a multicast policy, which I actually have a slide of. We have a slide of that, right? Do we have
Yes,
that slide?
we do.
Well, we do have that slide, yes. So I have a slide, and I'll show you exactly. But there's an IGMP policy. Those policy, who knows what the IGMP policy is assigned to? A NIC, a server, a port, what? You know. VNIC. I'm sorry, you don't know. You were close. VLAN. The policy gets assigned to a VLAN. So the snooping occurs on that VLAN. The default policy on UCS switch, snooping without the Querier. Okay, this is my last slide, right? Oh no, 2 more slides. In the olden days of 3 years ago, 5 years ago, many companies were setting up their servers in a core-agg-access type of situation, type of topology. In the new days, we now tend to use leaf-spine topologies. The difference being, if you notice all of these links that go to all of these different spine switches, you get typically, if you have enough ports going on here, 1 hop between this switch and any other switch down here. So that's important to know, 1 hop between each switch. They use protocols like Trill that you don't have to worry about, STP. You don't have to worry about ports. Spanning tree, thank you. You don't have to worry about spanning tree with them. But these are the new type of topologies. And actually, the troubleshooting can be a little different on these, and you can expect a little bit different performance on these. I'm not going to go deep into it. I just want to set the stage so you understand the network topologies you're going to be dealing with, because I'm assuming most of you have never run this before. Never had to run a switch before. How many people have ever had to run a switch before? Ever had to manage a switch? How many people have not ever touched a switch? It's a little bit heavier on the people who have side, so that's good. I keep talking about port channels and the linking that they do, so I wanted to put in a slide here to end this to talk about what a port channel really kind of is, or what a virtual port channel really kind of is. All it really is here's something. A server, maybe another switch, something, some device. And it will have links going to 2 different upstream switches. Now, you get a kind of a spanning tree issue if you try to put packets on both sides that can go up to, it'll go up to one switch, go across and down to the other. So we have a protocol to take care of that. But there's a peer link between these 2 switches. Could be 10 gig, could be 40 gig, depends on your switch. And any packets that go out here have a method of coming back down here. But the point is not to do that. The point is that when one side breaks, you've got the other side, and if it needs to go out to the world, it's got both ways to go. So it can either go out this way, or it can go up and over and out that way. That's the whole point of having a VPC. And there's a management channel, this is normally of some 1 gig links, that does a heartbeat to keep that VPC alive. That's the concept I keep talking about. So now I'm going to pass it back to Bhamik. He's going to tell you about best practices on how to do this.
All right, thanks, John.
And I'm going to interject liberally. Oh, you did it. Sorry.
We good?
Yep.
All right, so let's look at some of the design considerations and look across the board, right? So multicasting, QoS, bandwidth requirements, all those things. So from a bandwidth perspective, we looked at 1 gig versus 10 gig. One thing to keep in mind here is for vSAN, if you are, it's a fully functional network, 10 gig bandwidth, it's gonna support your large vSAN clusters, right? So 10 gig bandwidth is more than enough for the unicast and the multicast that we talked about. When you see either a performance degradation or any meaningful notice is around operational side of things, right? When you are either rebuilding a host or you are, if your host goes down and everything is moving around, object movements, that's when you will see either the rebuild times for VMs or access times to VMs might, that's when you notice the difference, right? So that's something to consider.
Please, don't skimp on bandwidth. Get the 10 gig switch. Make your life easier.
So 10 gig switch with, as I mentioned earlier, network I/O control with shares, and we'll talk about some of the considerations for configuring network I/O controls for vSAN VM kernel NIC, is what we recommend for doing QoS. I think I covered the priority flow control piece of it, and this will support most environments, right? So this is our baseline. Yes, please.
Is there a way to isolate the rebuild traffic so it doesn't impact your
Ordinary workloads?
Yeah, so I mean, we have these things, when you have disk groups on vSAN, when you have, if you have multiple disk groups per host and your objects are assigned, right? So that's all internal function of, how you minimize your failure domains and things like that. But once the object is placed, we don't have any of making it isolated in that fashion. So upfront, when you design your cluster, and this is not a networking requirement, but just an overall design, is you would once you create your disk groups, you wanna have failure domains at different levels, right? Just not within the vSAN, but also on the network side. That's how you will you'll make sure it's done, right?
So to make clear, 2 simple answers to that question. One is, yeah, run a separate wire and put it on a separate NIC, and then it can't interrupt your other traffic, right? The second is nobody does that. So use a VLAN, and you can put network I/O controls on it to limit its bandwidth or to limit its interference. You can use network QoS, but I wouldn't recommend it unless you're really, really good with networks.
Yeah, you typically
But
don't
network
need
NIOCs, better way to go.
Yeah, you typically don't need a network side QoS to the for the multicast traffic, right?
If you do it on your VMware distributed switch. Right.
So
Do one or the other, and probably do this, but don't go without.
So on the NIC teaming side, it's not designed to do bandwidth aggregation, right? So you'll have a VMK NIC, and you can team. If you have multiple VMK NICs, first of all, the requirement is that they need to be on different VLANs, and we don't recommend them, having multiple VMK NICs in different VLANs and doing the aggregation, because we don't find much. It's not designed for bandwidth aggregation. It's more for high availability. So keep that in mind. All right, so jumbo frames, again, standard vSphere practices apply. We do see reduced CPU consumption when you have jumbo frames enabled. So this might be helpful in a dense, like a VDI environment where you have high VM density per server. Even if you get a small CPU reduction, it's something you can leverage, right? But overall, our testing shows that these gains are very nominal, right? Because we are already using the TCP segmentation offloads and the LRO algorithms, right? So it's already baked in there, but as a best practice, it depends on your environment, right? If you have the practice of enabling jumbo frames, then yes, vSAN will leverage that and give you some CPU benefits. What we do, let me finish. What we do encourage you to do is when you configure this is you make sure you have end-to-end, right? If you have MTU size 1500 and even at a single point in your topology, that's going to try and chop all the packets from 9000 to, and that's when you see high latency, right? So keep that in mind. One of the things you would see in case you have a misconfigured jumbo frame or MTU size in your environment is because of some high latency, you will not be able to create VMs. Right? So if you right-click, say VM, it's a file not created. That's one of the symptoms of not having a proper jumbo frame configured. Right? So you need this end-to-end, and even 9000 versus 9124. Right? So you need to make sure that it's configured what's required on the switch. Right? So if it's 9000 on the host, then some switches you'll do 9124 to incorporate the 1024 versus 1000 packet size, right? So you had something to say?
This happened to me.
Oh.
Last week I was in Raleigh. I don't live in Raleigh, I live in San Jose, but I was in Raleigh. And I got a call from the office. The guys who were setting up the demo in the Cisco booth couldn't get vSAN to work. And so naturally they call me because they think I can. And I found the problem fairly quickly. They were trying to use MTU equals 9000. They had it configured correctly on the physical switches, but they missed a configuration on the VMware distributed switch. They forgot to configure that part. That's how this is. Any one little thing, any one little link in the chain is missing, and your vSAN network is shut down. You can, and we'll show you a picture of what that looks like later in the slide. But keep that in mind. MTU 9000, not necessarily your friend.
All right, so let's look at the multicast, right? So just so we understand, it's a requirement for the vSAN VM kernel NIC, and then you want to enable things like IGMP snooping and Querier on the switch side, right? So that's the recommendation. You can disable, you don't necessarily need snooping in environments where you have a completely non-routable dedicated vSAN VLAN, right? So if that vSAN VLAN is not getting routed, what will happen is if you don't have snooping and Querier enabled, as John mentioned earlier, it will do multicasting. All the NICs listening to that VLAN will get all the packets, but it's not an issue now because it's a non-routed VLAN that is only dedicated to vSAN. So this is also, I've seen this at customers where they would isolate it such that it's non-routed, dedicated, smaller environment vSAN, and you don't need snooping and Querier in case it's more of a overhead to configure those on the switches and make sure, talk to the networking teams and make it work. So that is also an option, right? So just to keep in mind. So some of the things as a vSAN admin or on the vSphere side you can do is isolate again using VLANs. Make sure trunking is done on that NIC if you are sharing the uplinks, right? So trunk your vSAN VLAN in that case. And then, and we'll talk about the redundancy topology, but make sure you have multiple, redundancy at multiple levels, right? So not only just the VM NICs going to different uplinks, but also going to multiple switches. As John would say, buy two switches instead of one. So make sure you have that topology, right?
And I say buy two switches, not one, not just because I work for Cisco, because honestly, I'm not exactly afraid of our future crashing. I think Cisco is going to keep going for a while now, whether you buy one switch or not. But you buy a second switch in case the first one fails. So you got another path. Because remember, this is your backbone. vSAN will not work without it. If you're going to get switches, get two and learn how to use them. And on the subject of multicast that he was just mentioning earlier, you can disable multicast in the Querier, but a number of switches, especially Cisco switches, come with with IGMP snooping already turned on.
Yeah.
So you got to figure out how to turn it off if you're going to do that.
Snooping is enabled, at least on the switches that I worked on, the Cisco Nexus switches and those that it's enabled by global, but you need to enable the Querier. You might need to enable the Querier, right? So snooping typically is enabled by default Querier. So that was on the layer 2 side. How many of you know that we do support vSAN over layer 3 now, or since 6.0?
What? Did anyone go to any vSAN presentations?
So
4 of you. Okay, good. Well, that's the same 4 that know that we're supporting L3. Okay,
so
right.
This is starting vSphere 5.5 patch 4. So it's supported for vSAN 6.0, but if you have this patch 4 on vSphere 5.5, it's also supported on 5.5, right? But you want to use it for 6.0. moving forward. So this is when you want to have, let's look at this image, right? So this is when you want to have multiple hosts across L3, right? So this is still not stretch cluster, right? This is just having 2 nodes on VLAN 401 in this case, and 2 nodes in VLAN 402, and then you have a upstream switch that is doing layer 3 routing of multicasting. You still need multicasting, right? So these 2 nodes on the left, A1, A2, and B1, B2, they're going to talk between each other. The difference now is they are separated by layer 3. You still need multicast routing, and for this we use the PIM protocol for routing, for multicast routing on an L3 switch, right? So you want to enable that functionality. We have a screenshot of some PIM commands on a Nexus switch, but it's gonna vary on the switch you are configuring.
You know what? It's actually a catalyst.
No, the commands
Or from a catalyst.
Catalyst switch.
Yeah.
Okay. It has the Nexus OS though.
Well, let's see again. Maybe
I
I'm
see.
wrong, but I think they're from catalyst.
And then you want to do static routes between the subnets on the switch, and then you want to do the same thing on the host, right? So you want to make sure that they are routable between the 2 networks. How many of you know we have stretch cluster for vSAN now? I think that was a good session yesterday. I think if you have attended that session, then you know how that works. Just a recap for those who were not in that session, what stretch cluster is for vSAN. This is an ability to stretch across multiple sites, right? So we support 3 sites, primary, secondary, and a witness site, right? And then the witness site is just metadata only, and the primary and secondary sites will have your vSAN nodes, right? So we support 3 fault domains, right? This is based on the fault domain concept of vSAN, and with this release we support 3, right? We don't support like 5 or more than 3. And these are expected to mimic sites again, right? So fault domains, you could have it in a single site, but typically with stretch cluster, we are talking about multiple sites here. So how does read and write work? Read locality is supported, right? So if you are reading from one site, you'll have data local to the site, right? So that's read locality. There is no such thing as write locality because we want to make sure it's redundant. So every write is acknowledged to the other site, and that's when that is constituted as a write, and then it's replicated. FTT1 is what we support, so you'll have redundancy of 1. And then, so that's the basic of stretch cluster, but I want to focus on the networking requirements, right? So there are 2 types of requirements you have to consider. One between the 2 sites, the nodes, primary and secondary, or the preferred and the secondary, and that is 10 gig or higher is required. And then latency up to 5 millisecond round trip is required, right? This is between the 2 sites. And for this, you would do L2 or L3 connectivity with multicast, right? So this is where, if you're doing L3, then you do the L3 multicast routing that I talked about earlier, right? For the witness, it's a little bit different, lower requirements and higher latency supported, right? Because this is just the metadata going to the witness. We don't have any user data there, right? So those are and then this is just L3 connectivity. This is no multicasting. This is just having a witness site somewhere in your, either in your data center or some other site. We're still working on the bandwidth requirements. So from the testing that we've done, we have this obscure formula that I was trying to understand, but we're still working on it, right? So it's going to depend on what type of sites you have. If it's a robo site and you have less VMs, then you need less bandwidth, versus if it's a data center and you have a large number of VMs and objects, right? So this is what you would do. Nodes times writes times 125 is what you need, okay? All right, so let's look at NIC teaming. I mentioned earlier it's not designed to load balance or do the aggregation, right? It's only designed to be for high availability, right? So you want to have redundancy again from multiple uplinks to multiple switches. Just a standard design, right? Again, vSphere practices still apply, and then we do support having multiple VM kernels, but we don't recommend them, right? So you don't want to have 2 VM kernels for vSAN in different VLANs and team them. It's not going to get you much, okay? So that's not recommended. Instead, you want to have a separate port group for each different traffic, and then you do network I/O control on those different port groups, right? So for example, if you are using one traffic type, and you can assign different traffic types to different uplinks, right? So you can go A, go B, and do the distribution that way, right? So that's what we recommend. So this is an example of uplink switch. And the only difference between in this case, the only difference between the uplink switch and a stack switch or a VPC type switch is that we don't have IP hash-based policy we can use if you are using uplink switches. And the reason is, that it needs either Ether channel or LSCP, which is a function of a VPC or a switches that are stacked, right? So everything is the same as before, but now you can use IP hashed theming if you want to use it in an either active mode or active passive mode. John mentioned about the leap spine. One thing I want to touch here is typically, and this is on the networking side, typically these are oversubscribed, right? So 4:1 is a common ratio we've seen. So what that means is if you have a 10 gig, I have 10 gig for vSAN. Yeah, but you only have effective 2.5 gigs because it might be four times oversubscribed. So when you either have performance issues or if you see some abnormalities in your performance, you want to talk to your network admin. You want to make sure that they understand that multicasting is configured everywhere, and then the bandwidth is there for vSAN. QoS, I'm going to build this one. So from a vSAN perspective, the vSAN VM kernel has unlimited shares, right? So if you use this feature, it's going to have unlimited number of shares. We recommend keep it that way. Don't set limits to vSAN VM kernel. Use shares instead of that because that's just a better mechanism. But leave it to unlimited to the vSAN vNIC and assign shares to your other traffic types, right? And then just keep in mind things like if you're using fault tolerance, then you want to have higher number of shares for fault tolerance because that could be a bursty type of traffic. And then for vMotion, you can have a share assigned, right? So this is how you can design, use NIOC for QoS. All right, so let's look at some of the config examples. John?
Oh, is this mine? Oh, okay. I was thinking about the previous question where someone was saying, if I've got a big rebuild going on or some kind of a recovery from a data loss or something like that, can I limit the vSAN traffic? And the answer is you don't want to. Just adjust shares so that the other traffic gets its turn to go through. Let the vSAN traffic, and the vSAN traffic, it may rebuild a little more slowly, but it'll rebuild. It'll be okay. But putting a cap on it just winds up wasting bandwidth, if that makes sense. Configurations. So, how many people use UCS?
You like that part?
Cool. I keep asking them that. I'm going to keep asking them that. I just like to see the hands go up. It's neat. I think now they're just doing it to please me anyway. So, in UCS, you will notice that there is here we are in the LAN section. And down here in policies, we create a multicast policy. In that multicast policy, you have essentially two choices. Well, two sets of choices. You can either A, turn it all off, disable it, or you can turn on IGMP snooping but not the Querier, or you can turn on snooping and the Querier. So I suppose that's three choices, isn't it?
Actually 4, but yeah.
Ah, the fourth would be what?
Grayed out, disable snooping and enable Querier.
Oh, disable snooping and enable Querier? Does not work. Tried it. Wouldn't let me do it. So you cannot, it will not let you like turn off snooping and turn on the Querier because that would be pointless. It would be querying and then just sending everything to the packets, to the ports anyway. So you create this policy, this is what we do in UCS, create policies, and then you apply that policy to a VLAN. Now, you'll notice here an address. There's an actual address, and if you look closely and think about what I said about multicast earlier, does that look like a multicast address to you? No, it is not. It is actually kind of random. Believe it or not, if you set the Querier in UCS on an address, you will not be able to ping that address. You will not find that address, but you will see packets that come from that address if you snoop, if you look at the packets, because that's the address it's going to say it's coming from while it's querying. You could put anything in here, well, nearly anything in here, and it'll work. I know your next question is, what's best practice? If I have that big a range of choices, what's best practice? I don't have one.
What I have done is I use an IP on the same network that the vSAN VMNIC is configured on, and I reserve one IP in the same same network and put it there.
Sounds like a very reasonable thing to do. Also, what some people do on an L2 on an all L2 network is they use what would normally be the gateway address, even though it's not really a gateway. It's not really the default route. Don't do that on L3 because you really have a gateway. That would be bad. Right, so here's my policy. And it's applied to this particular VLAN.
Yeah, so this gets attached to the VLAN, right?
So it's on a per VLAN basis, which made me ask the question, if I'm only going to put the VLAN on certain ports, why do I need snooping? Because it's going to make sure that all the multicast goes to all those ports anyway. Why do I even need it? If I just turned it off, everything would work. And the truth is I did turn it off and everything did work. But if it's off and that VLAN gets extended or somebody modifies that VLAN or adds things to that VLAN, then they're all going to get that multicast traffic too. So for future, better off with the Querier.
This is on the Nexus side.
It sure looks like it, doesn't it?
This
Yeah.
is for L2 though, so
I cannot figure out whether this is NXOS or iOS, but I think it's NXOS. He says it's NXOS. But I don't know, how did they get NXOS? They were using a Catalyst
this is for
4950.
L2. You're jumping ahead. This is L2.
I know, how did they, but they,
This is from your lab.
oh, this is from the, oh, this is not from our lab.
This is, yeah.
I didn't do that.
Next slide.
We didn't
is
do that.
L3.
I'm serious. No. L2 is not from our, that's not from our lab. Hey, back up. Okay, anyway. These commands may or may not work for you, but they are typical of oh yeah, I remember now. Yeah, okay.
Thank you.
They're typical of IGMP snooping type commands and how to turn it on, how to turn it off, how to set a Querier in a switch, in a Nexus switch. Now, again, your switch may vary. How many people use non-Cisco switches? Okay, that's more than I thought. I was really worried about, before I did this presentation, I can speak to Cisco Nexus switches. I really can't speak to anything else. And I can barely speak to them because I'm not really a networking guy. But you know, your mileage may vary. Your commands will be, may well be different. But what we're showing is turning on the Querier and setting up a static group. You'll notice the static group is connected to a particular interface. So you can physically limit, an IGMP group to an interface. There's a way to do that, that's static. And that becomes important when we do L3. For those people who do not understand what the heck I'm talking about when we say L3, what do we mean? It just means it's routed. That's all. Everything's not on the same, basically on the same subnet. Normally, VLANs are mapped to subnets. That's typical networking best practice, and that's what you normally see. So we'll interchange those two, VLAN L2 with subnet. But what L3 means is it's going through layer 3, it's being routed. When it's being routed, it's obviously got to get from one VLAN to the other, right? It can't all be on one VLAN or else you wouldn't put in a router. So these are typical commands for setting up this thing called PIM, Protocol Independent Multicast. All that really means is it's multicast without having to worry about anything in unicast. But PIM is your routing, multicast routing algorithm, and it creates these rendezvous points, and it sets up a whole tree schedule of where the multicast needs to be and what routers it needs to be on. It's way more complex than I'm going to be able to tell you about. But it's what the network guys are going to wind up using when you tell them, I have to do my stretch cluster of vSAN, and I've got to have multicast from here to there. That's what they're going to set up. Did you click that?
Yes.
Oh, God, I thought it was magic. Question? I don't know. The question is why dense mode instead of sparse mode or sparse dense mode? And the answer is I don't know the answer.
This is just an example, so this is what we had in the lab.
What I need to do is look into the multicast a little harder. Please see us in Barcelona, and maybe I'll have an answer for that. Go for it.
One of the questions that you would ask is why would you do vSAN over L3, right? So it could be use case specific, it could be security, or it could be just a lab environment where you have multiple servers in different VLANs or different networks, and you want to configure a vSAN cluster. Could be lack of IP addresses. This is relatively new, so I haven't had a customer deployment that has done vSAN over L3 yet, right? But this could be some of the reasons why you want to. This is again not stretch cluster, right? So this could still be L3 without doing stretch cluster, right? So I just want to make sure we highlight that. vSAN, you can do it over L3 and then stretch. You can stretch the sites as well, the two different things. All right, so let's look at troubleshooting and give you some tips on it, right? So before I go through this section, I do want to highlight that if you haven't used the health check plugin that comes for vSAN, and it's a free plugin part of the vCenter, we highly recommend using that. I think Cormac had a session on it, and it has all the built-in checks that it will do for your network health status. So please I recommend using that, right? What we're going to do is, what I'll go through here is some of the things that I've seen from customer deployments and things in the lab that we had to go through when things don't work, right? So one of the first things to keep a note is, by default, there is this thing as a 60-minute failure window in vSAN, right? So if there is an object or a component that fails, whether it's a network, a disk, or even a complete host, it could go in an absent mode, which means it will wait for 60 minutes. Because the notion is that it could come back, right? If it's a NIC failure or if it's a disk disconnected or a network issue. This is changeable, right? So there's a ESX command. You can change this to a lower value, but the thought process is you don't want to preempt everything and then something comes back up and you just moved all your data back and forth unnecessarily, right? So this is 60 minutes by default. So what you see typically when you have a network misconfig is partitions. This is one example where all the 4 hosts are in different groups with their own master and just an own group, right? There could be a scenario where you have hosts or a set of hosts in one group and the other set of hosts in another group. This could be classic when, if these hosts are going through if you are going through a topology where a couple of hosts are connected to one switch, the other 2 are on the other switch, and the switches don't talk, then they will have their own groups, right? So you could see multiple types of partitions here.
This is your first indication of trouble. That is your first indication that you have a network problem. The good part is it'll show up for just about every network problem. The bad part is it'll show up for just about every network problem. So you have no idea what's causing it, but you know it's a network problem when you have those multiple groups. They're all supposed to be in the same group.
So what are the steps you could do, right? So first of all, obviously you want to check if vSAN is configured on your VMK NICs. These are 2 examples. You can do it on the ESX command, or if you're using RVC tool, you can go in RVC and do that. You want to make sure they're on the right VLANs, right? So you can check that from a IP interfaces list. You want a VMK ping. If you are using jumbo frames, do it with 9000. And this is where you can check for multicast pinging, right? So this is what you will do. You want to make sure you check your MTU is set properly, and you want to get the multicast settings as well, right? If you go a little bit more advanced, you can use a VSI tool, which is an undocumented tool that our support often uses. So, this is before you tweak stuff around this utility. That's my caution. Do not use it unless you know what commands you are using, right? So in this case, what we do is we basically run this command to configure each host to respond to an IGMP echo request, right? Do this on all hosts, and then run the VMK ping command, right? So when you enable this to respond to IGMP echo request, and then you do the VMK ping, if it's all working fine, you'll only see responses from your master and your backup, right? So that's what the last piece says. If you don't see any response, then that means the master and backup are not doing this. There's no multicast. Remember I said the master takes the info it has and gives it to the backup node? Then that's not happening because something is wrong, right? So this is one way of troubleshooting in case you've tried all the basic stuff and you don't know what's going on. Another way is to do TCP dump, right? So this is again, if everything is working fine, you will see your backup and master nodes doing the hard bits, right? So that's an indication that things are working fine. But if you don't see anything, or if you see multiple IP addresses, right? If you see like 2 sets of IPs doing this, then you know the partition has 2 masters, right? You have 2 partitions and you have different masters.
That's an important point. So these are commands that these commands are all on the ESX, host. You SSH into the ESX host and you run it from there. If you start seeing IP addresses that you don't recognize, somebody else is trying to make a vSAN on the same network as you. And it's your job to hunt them down.
Or it could be that you have multiple vSAN clusters, and they are all, you have multiple masters doing it, right? We do support having, so by default, right, each vSAN cluster would have this multicast IP addresses. If you have multiple vSAN clusters, they're going to use the same IP addresses by default, and that works, right? That's fine. But you might want to go in and change that, and there's a KB on how to do that, just because you isolate that traffic and you don't see each other's multicast, right? So
Because some knucklehead's trying to put a vSAN on your network.
all right, so let's look at what you do on performance side, right? So a couple of ways, right? IP perf, obviously, the one way to see what you're getting, but also vSAN observer, right? So how many of you have used vSAN observer? Yeah, so I think everybody should use vSAN observer. It's a very handy tool. You'll get graphs. It's not the best UI type of tool, but it's very handy for vSAN, right? Along with ESX top. So obviously you want to understand what the latency requirements are for your apps, right? Different apps would have different latency requirements. So doesn't mean a spike of 11 latency, 11 ms latency is bad for your VDI. It depends on the application, right? Some applications you need much lower latency. That's one thing to check. IOPS might not be uniform across hosts because again it's a distributed object based storage. You might have different number of objects on each node, right? So when you do reads and writes, your IOPS will not be the same on each host. So if you get, it won't be, I mean, it could be ununiform, but depending on how the objects are placed, but you could see different IOPS out of different hosts, right? So you could see, say, 10,000 IOPS per host. You might see 25,000 IOPS on another host if it has more objects, right? So that's something, one time we saw that and we had to do a bunch of things because we thought some host is not performing, right? And then we understood that it has less number of objects because the object placement again is automatic. We don't manually do object placement in vSAN. Another thing to consider is when you have abnormal latency values, that's when typically you are having some network issue as well, right? So vSAN Observer will give you that consistent graph. You can build this over a period of number of time, right? Days, hours, and you would see, if you see abnormalities there, that would typically should correspond with some issue in your network, right? So if you want to go to the network admin and say you are having some issues, I've had to use this type of graphs to actually even prove that there is some issue going on because everything just looks fine, right? So those are the things to keep in mind. All right, so to wrap it up and then take a question or two if you have time. Some of the key takeaways, again, leverage your vSphere best practices. Take a look at all the vSAN best practices that we talked about. Make sure you understand multicasting and how it's configured in the network, right? Different switches would have different types of configurations, so make sure you get that down. Before you do L3 or stretch clusters, just evaluate the use case. Make sure you know why you're doing it. It's new, and you want to make sure you get that down because it's going to be more complicated than just having a vSAN cluster sitting in a layer 2 network, right? So that we know. And then last but not least, also refer to your networking vendor best practices, right? Whatever switches you have, make sure, vSAN works on all topologies, right? Leaf's fine, core, aggregate, but make sure you follow the vendor best practices as well. If a switch doesn't need snooping Querier on a VPC configuration, make sure you follow that. If it needs it, make sure you do that, okay? So hopefully this was of value to you. Again, thanks a lot for sticking out on the last day. And with that, we'll open it up for questions, and otherwise have a safe trip back home. Thank you.
Hey, nice job. We managed to wrap it up with 2 minutes to spare. Did my mic go off? No, it's on. Okay, good.
Can I ask a question?
Yes, yes.
Yeah. Grab a mic.
Thanks for all the background on the spine. Do you have any insight on not using one for direct connect for robos or poor starving home users that want to
Sure,
stand
just
up to
using
the
direct
cluster?
connect to the switch.
Direct connect without a switch, node to nodes.
Oh, directly connecting the servers?
Yes.
Yeah, I don't think that's supported.
Yeah, it's not.
Pretty sure
so
no.
a buddy of mine tried it, didn't work. Wondering maybe static routing or something like that might have saved it. Any insights or?
So if you're asking how to make it work,
Right.
I don't know.
No, any ideas? Yeah, just ideas.
No, I don't think it's not supported, so you don't want to do that.
And so how could you make it work? I don't know.
Yeah.
I'm not sure.
Have you guys even looked into anything like that? Maybe trying to slash, 20 grand off a remote office that might only be
So
trying
what's
to get a few.
the need? You don't have a switch in there?
No, think about a remote office, branch office that was
But
just
they-
going, a 3 node, maybe 4 node.
but you still have a switch in a robo site, right?
Sure, sure.
So
Maybe.
why do you want to
So
do
say
it?
it's a 1 gig switch and you want to have 10 gig capabilities, and 10 gig NICs are cheap, but 10 gig switches are really expensive.
Yeah,
What
I don't-
topology would you use, right?
All direct connect, one-to-one.
But what does that mean? So if I've got 3 servers, which I have to have,
Right, and you had
how do I
3
connect those 3 servers to each other?
You had 3 10 gig interfaces. You can connect each one to each one.
You do 3 10 gig interfaces
Yep.
and then span them out that way?
So node number 1 connects to 2 and 3.
Yeah,
node number
I
2
don't know.
connects to 1 and 3.
I've not a clue. Don't know why it wouldn't
Yeah.
work. Don't know if it would work. Not a clue.
Cool, thanks.
We haven't.
Could be fun. Oh yeah, there's the whole crossover cable issue, right? So, I don't know. Does that matter? Does that matter in the 10 gig, the new 10 gig connectors? I guess it probably does. I don't know.
Yeah, so to answer you, we haven't done it, we don't support it, we don't see a need, I haven't seen any requirement around that, because typically the robo sites have a switch, and 3 nodes minimum, you would end up having a, I mean,
So, and vSAN does work on 1 gig,
it could be any switch, right? It could be L2.
but to buy 10 gig NICs and not 10 gig switches,
All right, next question.
I don't know, bug them for money.
Good afternoon, Mr. Brazell, Mr. Kennedy. I have a question for both of you that no one here in any of the technical capacities has been able to answer, and perhaps with you two as my audience, you can either answer or perhaps
We seek to
commit
uphold that
resolve.
standard of being unable to answer, so.
Well, it will be up both of you gentlemen's alley. We are a VMware shop as well as Cisco. We use the Nexus 1000V because it's the network preference, and our organizations are separated in that way. It's beneficial to us. Rolling and considering vSAN, I know that 5.5 specifically says we support only VDS. Can't find anything in 6.0 or 6.1
So-
that says one way or the other. Can
So
we
sa-
use
Same
Nexus
thing right
1000V?
now, we don't have N1K support for vSAN, but that's something that Cisco is working on. So, I mean, it's still gonna be a vSphere base, so vSphere supports N1K, so it works, but it's not supported. So that's it's a test process that's going on, and once the testing is completed, it will be supported. So it's today, vSAN 5.5, vSAN 6.0, only the standard switch and distributed switches that's what's supported.
Okay, Mr.
The
Kennedy.
good news is that Nexus, we have tested it, and it does work, and they know how to set it up. We even have config instructions. We simply haven't communicated that to VMware yet. And I know the guys who did it, and
As your
so it
federal-
works. Sucker works. So
As your federal customer, is there anything that we can do to help persuade either party to expedite or better commit resources to
again, so
accomplishing
the best way to
goals?
motivate both of these companies is to ask them for it, and not us, because we're marketing
No, I
guys.
understand.
Ask salespeople; they communicate those things back. But we will communicate that. I guarantee you. I will talk to the Nexus 1000V guys. I don't need to convince; they're convinced already. I just need to talk to some other people internally to get the thing moving.
All right, very good.
So, but thank you for that, because now I can take that home with me.
Thank you.
You know who he works for? Maybe you should get his card.
Yeah, actually, could I get your card? That's not a bad idea. Can I get your card, sir? Sorry? Can I get your business card? Yeah, I'll bring it to you shortly. All right, thanks.
Yes.
Would you recommend like the lower end, Catalyst with 10 gig ports, like those 4 uplink ports for vSAN type of traffic? Like just use the uplink ports. This is kind of following up with smaller branch office type of.
Well,
setup.
wait a minute. Are they 10 gig? Are they 1 gig ports with the 10 gig uplinks?
Yeah,
Would I recommend it?
yeah.
So it's within the spec. It's within
so-
the guidelines. But
so again-
I can't say I'd recommend 1 gig ports, right? Because we've been saying through this whole thing, do 10 gig. But
So if
it
you
will
do-
work, and it's
if you-
supported.
If
so.
you do all flash vSAN, then you need 10 gig. If you do hybrid vSAN, then you can do 1 gig, but we don't recommend it, because what will be your cluster size and things like that, right? If you have a really 3-node deployment with 1 gig in a robo, and you have less VMs and less number of objects, then yeah, 1 gig will work, right? But if you're looking this in a data center and you are gonna have like 19 hosts and mission critical apps there, VDI, no, we don't recommend that. So depending on
I think you guys need to look into the prices of the Nexus 9000, because they're cheap now from what I hear. I don't know, they just give them to me, but I hear that they're really relatively pretty inexpensive. You had a question?
Yeah, I want to thank you both for the presentation. It was great. We are a VMware as well as a Cisco UCS shop, and I'm going to recently come across some hardware that we're going to take off production some older 6100s XP fiber interconnects with a couple of chassis and a few M2 blades. And I was wondering if we can, they're all blades, so we can't really do vSAN on the blades, but I wonder if I can put a couple of C-series in that cluster and maybe make a vSAN to
So
kind of
two
play
things.
with and keep it contained.
So
Go for it, yeah.
yeah, so vSAN, we're working on supporting vSAN for the blades. So that,
Well, there's only a limit of drives that I can put
exactly,
in there.
so that's
They're
the
not,
issue.
they're not working on supporting vSAN for the old blades.
No,
They're working on supporting vSAN for the
But
new
regardless of
blades.
the old or new, you still have the 3-slot drive limitations on the blades, right? 3 or 4, 2, 3 with the PCIe slot, I guess you can use 3. But yeah, so yeah, as I mentioned, what we don't recommend is the unbalanced config, right? So in this case, you would have some blades that are compute nodes and then C-series servers
Right.
that are storage nodes.
Right.
That's an architecture we don't recommend with vSAN. So
It's,
that's
it's
the
not
problem.
best, it's not best practice at all.
So nothing stopping you from doing that, but you're going to
works.
hit some component limits on vSAN, and we don't recommend that out of the box. So that's still an issue. What we do is then so with Cisco UCS, specifically with blades and C-series, even if you have the blade supported initially, you'll have like a uniform architecture where you either have a small capacity on, your blades still need to contribute storage, right? But
They
you can
should.
have blades and C.
I could, I guess,
Yeah.
if I get.
Well,
Yeah,
so
you
no,
could.
so okay, so vSAN is not certified to run, the blades and their itty bitty
mixed
tiny
environment?
SCSI controllers are not on the vSAN HCL. And because their SCSI controllers on the Cisco blades weren't chosen for that. We are beefing up those SCSI controllers soon so that they can get on the vSAN HCL, but right now they're not. Now, does it work? Yes, I've had it work, but I've also had it blow up in my face. So I would not recommend using blades, Cisco blades, to donate the storage at this point. They don't have the controllers.
His
for
question
it.
is after
Right,
it's
so
supported.
I wasn't
Yeah, I
going too
understand.
far into the, because again, I have a limited space on the 2 drives, and it's not really going to
So yeah, so
My
once
thing was creating like a 3-node cluster in that domain, and then being able to
Like 3
enable
C-series?
so let him finish.
inside of the same fiber interconnects, connecting
Yeah.
to the same
Yeah.
fiber interconnects, and so that way keeping the environment contained and not having to hit the switch.
Right.
Because I can just do a VLAN that's only in that domain.
If I was going to do
the
it,
jumbo frames
that's
and
how
all
I would
that.
do it.
I'm sorry?
If I was going to do it, that's how I would do it. Get 3 C-series, make them my storage, and maybe let the blades use. But again, they don't recommend
It's
the
not
unbalanced
supported?
cluster thing.
We don't recommend that.
It's supported,
Oh,
but it's
it
just
is?
not recommended.
Oh, okay.
If you're going to vMotion,
So-
you're
so-
going to
If
need
I
EVC.
was
Sure.
to use those 3
Yeah, so
C-series
it's not a
for
good idea
computing nodes,
because
but I
it's
wouldn't.
going to hit some component limits on vSAN. That's why we don't support it. So you could have 3 blades and 9 rack servers and have more storage there, less storage here. It's going to quickly go unbalanced in terms of how much storage these guys contribute versus the racks. And that's what we don't recommend is an unbalanced config. So yeah, stay tuned. Maybe there's something on the vSAN side that changes.
Okay. And then I guess to follow up on that, and
Yes.
this will be quick. Could I replace those old chassis and blades with C-series and
Yeah,
maybe do it like that?
yes.
Yes, we hope you do. And the C-series work managed.
I
So
mean, we already have a cluster for Hadoop that
Yeah.
we already encompass the whole
Yeah.
jumbo frames and all that under the same domain, so that's separate. So I was wondering if.
So yeah, put the C-series. I always do C-series managed. I never do them unmanaged. I always do them connected to the fabric interconnects. But yeah, man, how much testing have we done on that? That's been done to death. Yeah.
All right, cool. Thank you.
Yes, sir.
Just, there seems to be a lot of emphasis around, especially around stretched clusters around a 10 gig environment. What if you had a high latency environment and you wanted to use something in a hybrid fashion?
High latency environment?
Yeah.
So those were the latency requirements, right? So if you are stretching the vSAN clusters, you need up to 5 millisecond round trip is only what's supported.
What about if you were in a hybrid scenario and you had something less than that?
What do you mean a hybrid scenario? Meaning?
I mean, less than 10 gig in a 1 gig scenario.
No. So for a stretch cluster between 2 sites,
You have to have 10 gig.
you gotta have 10 gig
Okay.
and up to 5 millisecond latency. Those are the.
That's what they're supporting, yeah.
Okay, so there's no other support for another, if you were less than that, you'd have to be in the same site.
Correct.
If it was a 1 gig scenario.
Correct.
You would have
Yes,
to have less
yes.
latency. So you cannot
Yes.
go over the 5 millisecond latency no matter what you do. Stretch
Okay.
it, squeeze
Stretch
it.
it or
you
even
can't
if
go
it's
over the
local.
5, because that's your latency. That's sort of the definition of stretch, right? Is latency across the network. That's the impact, right? That's the,
Okay.
you know, if the servers are next door, but they've got 100 milliseconds of latency because you've got so many routers
not
or whatever
gonna
in the
work.
way, you know, it doesn't matter that it's stretched. It's the latency is what's going to kill you.
What's going to
so.
happen is the multicast communication will get delayed and it will think the host is not participating in those things, right?
It's multicast that's going to bollocks up on you first.
Just the health checks that happen, right? Not specific to multicast, but the health checks that happen is the latency. It needs to come back to the master in that latency.
Okay. And a second, just,
Yeah.
you had talked about like the VM kernel setup, and I was a little confused when I was testing this in the lab, because in my mind you have the management interface and you have like a vMotion interface, and I tried to add in another VM kernel interface, even if I was just using one NIC, but where you actually enable the vSAN traffic to go across that VM kernel, it wasn't available. And you had talked about in the
need
slide that you couldn't
dedicated-
have multiple VM kernel interfaces.
You need a dedicated VM kernel for
Yeah.
vSAN.
So you went to enable vSAN traffic, but it wouldn't let you enable it?
It wasn't there. The only place it was allowing it was on the management interface.